dear students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So, in the lecture series of this subject, solid waste management, we are going to discuss about the flue gas cleaning system. So, previously I have discussed about the incinerator and the types of incinerator. So, from incinerator, when the flue gas will come, what happened in the flue gas? Many chemicals are there. Because this is just a burning in incinerator, what we'll do, we'll burn the solid waste, some toxic waste also. So when the flue gas will come outside, that gas will contain some toxic metals also. So now today we will discuss about the cleaning system that we are adopting for the cleaning of these flue gases, that gases is coming from the incinerator. So what happened? First of all, I will discuss about the flue gas. This flue gas is what? It is about 80% of the waste that is transformed into the flue gas during the waste incineration process. So what happened during the incinerator process? When the waste is going to burn, 80% of the waste is going to transfer into the flue gas. So the 80% of the gas, as it has been given, 80% has been transferred into the flue gas. So this in the waste incinerator process. So what happened? In the flue gas will contain many problematic components, some toxic metals, some toxic things like some dust particles, some dust are there, some acidic gases are there, NOx are there, heavy metals and organic pollutant. So like that we can say that most of the components in the flue gases are like dust and some particles, some acid gases like HCl and HF and SO2, NOx, heavy metal and organic pollutants. So what happened? So next point is like that flue gas must be extensively cleaned before being released into the atmosphere through the stack of the plant. So before releasing it into the atmosphere from the stack of the plant, it should be cleaned, because it will contain some of the these flue gas are very toxic in nature, because it will contain some dust particles, acidic gases, SOx, NOx, heavy metals and organic pollutants. So to release it into the atmosphere via the stack gases, this should be clean. And the most important point is that about 80% of the waste that is transferred from the flue gas during the waste incineration process is contains toxic element, either some dust particle or some HCl or some HF or some SOx, some NOx, some heavy metals and many organic pollutants. So because of that only, it should be extensively cleaned. It should be cleaned in a very good manner, so that it can be disposed out in the atmosphere. But if we will not clean it in a good manner, then what happen? Again, the pollutant will release into the environment. So that's why cleaning is the important thing of this flue gases. Now comes to the next point, that is flue gas. Which type of flue gas cleaning system is acquired nowadays? So this cleaning system is required to reduce the concentration of specific pollutants to concentration well below the respective air emission limit. Obviously, this should be cleaned up to a level so that the pollutant concentration is reduced well, and it will be comes under the standard of the air emission limit, and the specific type of pollutant that can be cleaned. So these pollutants can be divided into the categories, either in a dust or in an acid gas or PCDD or some NOx. So these are the 4 categories where it has been divided. Some in this pollutant system, some are in the form of dust, some in the acid gas, some in the PCDD, and some in the form of NOx. So this cleaning system is required, very much required, to reduce the concentration of a specific pollutant to concentration well below the respective air emission limit. And flue gas must be extensively cleaned, as I have already discussed that. It should be extensively cleaned before being released to the atmosphere from the stack of the plant. So before it releasing from the stack of the plant, that flue gas should be cleaned extensively, so that the pollutants, toxic elements, some acid gases should not release into the atmosphere. Otherwise, if we will not treat it properly, then what happens? Then again, no use of this incinerator. because 80% of the waste is converted into the flue gas, and most 80% will have, mostly they will have some dust, acid gases, some NOx content, some SOx content. So before releasing it into the atmosphere, it should be extensively cleaned at the stack of the plant, so that it will be not enters again into the atmosphere. Otherwise, again the toxic element will enters into the atmosphere. So, and it should be, cleaning will be like up to the level where it will be reduce the concentration of a specific pollutants well below the respective air emission limit. So it should be cleaned up to a concentration limit of the specific pollutants, up to a concentration which will well below the respective air emission, up to a respective air emission limit. So cleaning means like that. It should be cleaned. It should be reduced. It mainly, it will reduce the concentration of the pollutants. It is going to reduce the concentration of pollutants up to a permissible limit, up to a limit that will be allowed, that will be permissible as per the air quality index. As per the air quality index, that pollutant should be allowed up to a limit. So to remove it and to clean it and to make it a permissible limit to up to a level where it will be, it can be allow the air emission limit, and now we can disperse it easily into the atmosphere. Okay. So see this is the picture. This is it will show the flue gas cleaning system. So how this flue gas cleaning system will work. So flue gas cleaning system requires reduction in the concentration of a specific pollutants concentration well below the emission limit. So it will require the reduction in the concentration of pollutant, toxic substances, toxic chemical up to a level where the emission limit will accept it. So see, this is the furnace. You can see the picture. From the furnace, flue gas will come like this, and some air preheat heater is there, and then it is going to collect here. And here it has been installed with some of the cleaning system. Then ID fans are there. Then after that, it will enters into the chimney, and then it can goes out. It can enters into the atmosphere. So that chimney stack, we can say it like many name. So this is the actual picturization of how this flue gas cleaning system will work, and where this system has been installed to clean the atmosphere, to clean the air. So the flue gas cleaning system requires reduction in the concentration of a specific pollutants concentration well below the emission limit. Well below the emission limit, up to that limit which can be acceptable. The cleaning of the required reduction will be required to clean the air pollution, to clean the flue gases, so that it can be easily dispersed into the atmosphere. It can be easily enters into the atmosphere. So this is just a picturization of the flue gas cleaning system, how it will work. Now see, induced fan is there. Induced fan, what this ID fan is doing. Induced drought fan is there. It is the key component of the plant. Here I have seen you. I have already given you the picture, that is induced drought fan is there. That fan will clean out the flue gases, and then it will allow to enters into chimney, and then from chimney it can enters into the atmosphere. So key components in the flue gas treatment plant. So what it is doing, it is going to ensure that the transport of flue gases from the furnace through all the process steps of the flue gas treatment plant to the stack. It is going to ensure that the transfer of flue gas from the furnace through all the processes, that is steps of the flue gas treatment plants, to the stack, and it is located in the back end of the process train. That is obviously this ID fan is located in the back process train. The ID fan also ensure that no polluted flue gas escape from the process equipment by providing a reduced pressure therein. So it is located in the back end of the process train, and the ID fan also ensure that no polluted flue gas escape from the process equipments by providing a reduced pressure therein. And flue gas transport is quite demanding in terms of power consumption, and the ID fan is the largest single power consumer in the entire waste incinerator plant. This flue gas transport is quite demanding in terms of power consumption, and the ID fan is the largest single power consumer in the entire waste incinerator plant. So this ID induced drought fan has been installed in the incinerator plant to ensure the transport of flue gas from the furnace through all the processes steps of the flue gas treatment plant to the stack. And mainly what happened, it is located at the back end of the process train. The ID fan also ensures that no polluted gas can escape from the process equipment by providing a reduced pressure therein. And flue gas transport is quite demanding in terms of power consumption, and the ID fan is the largest single power consumer in the entire waste incinerator plant. So this induced drought fan is working very much effectively in a flue gas treatment processes. It is a key component in the flue gas treatment plant, and it is going to ensure the transport of flue gases from the furnace to all the process and steps of the flue gas treatment plant to the stack. And mainly where it will be located, it is located in the back end of the process train. And the ID fan also ensures that no polluted flue gas escape from the process equipment by providing a reduced pressure therein. And the flue gas transport is quite demanding in terms of power consumption, and the ID fan is the largest single power consumer in the entire waste incinerator plant. So this is all about the induced drought fan. And next is called as fabric filter. Fabric filter is also installed so that it is going to filter the flue gas. So what happened in the fabric filter, the raw gas passes through fabric bags, which is supported by a metal case. So you can see that some metal case is there in that fabric filter. So this metal case is going to work, and the gas flow is commonly from the outside to the inside. Obviously gas will enter the outside, and then it will goes to the inside. And then what happens, the dust stays on the outside of the bag is periodically removed by an air pulse opposite to the filtration direction. The dust stays on the outside of the bag and is periodically removed by an air pulse opposite to the filtration direction. And its removal efficiency is 99 to 99.5%, and it can operate up to a temperature up to 250 degrees Celsius. So this fabric filter is very much effective, and its removal efficiency is approx 99 to 95%, 99.5%. So it is very much effective, and it can work up to a temperature of 250 degrees Celsius. 250 degrees Celsius. So this is a basic description of the fabric filter. And the raw gases passes through the fabric bags. The raw gas pass through the fabric bags, which is supported by a metal case. Metal case is there into the fabric bag, and the gas flow is commonly from the outside to the inside. Gas will come from outside, and then it will pass through the inside, and the dust stays on the outside of the bag. Obviously dust will remain outside of the bag. So this is showing in the pictures also. You can say compressed air will come from this side, and the wire supported case are there. Some case are there, that is wire supported case, and the raw gas will come like that, and it will come from here and it will goes from there. So that dust will be collected, and then it will be fall down, and here it will be collected as a fly ash. So this type of fabric filter is basically collected in the thermal power plant, is basically installed in the thermal power plant, because what happened, due to burning of coal, some little bit dust is there. That dust is called as fly ash. So to filter this dust from the chimney, from the stack, this type of fabric filters has been installed, and the dust stay on the outside of the bag. Fabric filters are there, and that will be made up of some of the metal case, so that what happened, the air will come, and the dust will stays on the metal case, and then it is going to collect at the bottom, and with the name of that is called as fly ash. So you can see the picture, fly ash will be collected here, that is called as discharge hooper, and the clean gas will come out from this type, and Venturi nozzles are there, filter house is there, and filtration and cleaning and filtration unit are there. Then again what happened, raw gas, like this you can see, raw gas will enter into this, so filtration unit are there, and this is called as discharge hooper, and it will be collected down, it will be collected down here, and that is called as fly ash. Mostly the dust particle, this fabric filter will work for the dust particle, and fly ash is like a dust particle, and when it will be collected below the surface, and that is called as fly ash. and the dust stays on the outside of the bag, and it is periodically removed by an air pulse opposite to the filtration direction. It can be periodically removed from the by an air pulse opposite to the filtration direction. Its removal efficiency is also very good, that is 99 to more than 99.5%, and it can operate up to a temperature of 250 degrees Celsius. And the next what happened from the this raw gas passed through the fabric bags, which can be supported by a metal case. This is just a working principle of this fabric filter. So from outside to inside, and finally the gas will come out with clean gas will come out, and the dust is on the outside of the bag and periodically removed by the air pulses. It will be removed by the air pulse opposite to the filtration direction, and the outside to inside, like that the gas will work from outside to inside, and finally from the clean gas will come out, and the dust is on the outside of the bag and periodically removed by the air pulse opposite to the filtration direction. So time to time the solid that settle will get removed out, and what happened with the time, the dust will be collected, that will be removed out after some time. The only problem related with this fabric filter is its operating temperature, which should not be more than 250 degrees Celsius, because these are the cloth bag and fabric bag. So because these are the fabric bags and some cloth bag, that's why it will be not work more than 250 degrees Celsius of temperature. So this is the only negative point that is related with this fabric filter. Otherwise, this fabric filter is very much effective in collecting these dust particles, and it won't work more than 250 degrees Celsius of temperature, because of this is a cloth is only there and the fabric bags are only there. Otherwise, it is a very much good and it is a very much efficient, because it will be give efficiency up to 99 to 99.5%. Now, next device is the Venturi Scrubber. So, Venturi Scrubber is also installed on the flue gas, so that it is going to accelerate it to a high velocity by passing a funnel with a reduced cross-sectional area, that is called as Venturi, and where also water is injected and atomized. And the water aerosol that is caused by flue gas pick up a large fraction of the ash particle. The water aerosol is there that is caused by the flue gas. The working principle of Venturi Scrubber is like that. It is accelerated to a very high velocity by passing a funnel with a reduced cross-sectional area, and where what happened, the water is injected and atomized also. So the water aerosol that is collected and caused by the flue gas, pick up a large fraction of the ash particle, and the water droplets are subsequently removed in the cyclonic separator. So after what happened, the water droplets are subsequently removed in the cyclonic separator. If HCl is present, hydrochloric acid is present, it dissolves in water aerosol and reduces its pH, creating corrosive condition, and needs treatment prior to discharge or reuse. So this is a whole process that is related with the Venturi Scrubber. The flue gas is escalated to a very high velocity by passing a funnel with a reduced cross-sectional area, and where also water is injected and sometimes atomized. The water aerosol caused by the flue gas pick up a large fraction of the ash particle. The water aerosol which is there, that will be collected by the flue gas, they are going to pick up a very large fraction of the ash particle. And then what happens, and subsequently it will be removed by the cyclonic separator. And the HCl is present, hydrochloric acid is there. It is going to dissolve in water aerosol and reduces its pH and a corrosive condition, and needs treatment prior to discharge or reuse. So it will need some treatment before discharging, before its reuse. But this HCl is a hydrochloric acid that has been added to reduce the corrosiveness and to increase its pH. And so that it is going to reduces the corrosive condition, and it should be must treated and must reuse. Thermal treatment is required before it should be discharged or reused. So this is a description of the Venturi Scrubber. Now this is the picture of the Venturi Scrubber, the diagram of the Venturi Scrubber, and this is a real Venturi Scrubber which has been installed in the Texas, US, and its removal efficiency is 99%. So you can see that raw gas will enter from this side, and Venturi are there, Venturi throat is there. So from here it will be gas will enters into like this, and by this passing like this with by using some cyclonic separator, it will works with a centrifugal force, and this cyclone separator will will make the clean gases outside, and dust particle will be collected here in the form of slurry, because the dust will be added with the water in the form of slurry. This has been collected in the bottom of the Venturi scrubber. So this is the picturization of this Venturi scrubber, and this is the actual picture of the Venturi scrubber which has been installed in the Texas, US, and its removal efficiency is also very good, that is up to 99%. And now comes to the cleaning of acid gas. How this acid gas will be cleaned? So acid gas can be removed by a number of technology that is called as either wet system or dry system. Acid gas can be removed by some of the method that is called as either wet system or dry system. So wet system is like normally applied after fly ash has been removed, typically in the electrostatic precipitator. That what I have discussed, and it works on the principle of absorption of gas component into a liquid. This is called as wet system. Wet system will basically involve the absorption of gases components into a liquid. Their efficiency will depends on the available surface area of the liquid, which controls the mass transfer from the gas into the liquid transfer. So what happen in wet system, this wet scrubbing is normally applied after the fly ash has been removed, typically in the electrostatic precipitator. It works on the principle of absorption of gases components into a liquid, and its efficiency depends on the available surface area of the liquid that is going to control the mass transfer from gas into the liquid phase. So this is the wet system that is related with the acid gas cleaning system. And now comes to the dry system. So what happened? It is a two-stage installation with an initial acid scrubber is there that is going to remove HCl and HF and mercury, that is followed by a slightly acidic or neutral alkaline scrubber that is going to remove SO2, sulfur dioxide. So what happened? In an acid gas scrubber, it is a basically two-stage installation process that when the initial acid scrubber is removed by hydrochloric acid, HF and mercury, that is followed by a slightly acidic or neutral alkaline scrubber to remove SO2. And next what happened? Wet scrubber is there. So in wet scrubber, that is be often operated with discharge of liquid effluent. So this wet scrubber are operated with the discharge of liquid effluents and require neutralization to neutral pH and an efficiency removal of any heavy metals or other toxic contaminants. So this wet scrubber are often operated with discharge of some liquid effluents, that is 100 to 300 liter per ton, and it requires neutralization to neutral pH. So neutralization will be required to make the pH neutral and efficiency removal of any heavy metals or other toxic contaminants. So you can see this is the actual picture of an acid gas scrubber system in the Pune that has been installed to remove the acid gas scrubber system with a two-stage installation process with an initial acid scrubber to remove hydrochloric acid, then HF and mercury. That is followed by a slightly acidic or neutral alkaline scrubber to remove sulfur dioxide. Okay. Now comes to the next point, that is called as dry system. So in dry system, CaOH2 and NaHCO3 are injected into the flue gas. So these two are injected into the flue gas. NaHCO3 are injected into the flue gas to make it neutralize. So with the injection of these two gases, it will be this flue gas for the neutralization of acidic gas component. It is going to be neutralized. In a dry process, the agent is injected as a dry powder, maybe together with water, while in the semi-dry system, the agent is injected as a slurry that dries the flue gas. So like that, in a dry process, this agent is injected as a dry powder, maybe together with water, while in the semi-dry system, the agent is injected as a slurry that dries the flue gas system. So these two are used, and it will be inserted into the flue gas to make it neutralized. And then after making it neutralization, we can directly disperse it into the atmosphere, and that its toxicity will be removed and toxicity will be reduced. Okay. Next component is dioxin and furans. So dioxin and furans are very dangerous, and how it will be cleaned. So first of all, what happened? PCDD is like polychlorinated dibenzo p-dioxin. PCDD is like polychlorinated dibenzo p-dioxin, and dibenzofurans are also there, that is already present in MSW, that is present in municipal solid waste, but they are almost totally destroyed in the combustion chamber. So this dioxin and furans are almost destroyed in the combustion chamber. So what happened in the boiler, when the temperature will comes down up to a 200 degrees Celsius, new formation takes place. That is called as gaseous PCDD, and can be absorbed on activated carbon in a bed filter or in a carbon injection process in combination with the baghouse filter. So what happened? Obviously, this furans and dioxin are present in the municipal solid waste, but it will be destroyed when it will be going to be burned. But when it will come to the boiler, the temperature will going to be down up to a 200 degrees Celsius. So in that condition, it is again going to be released. It will be again going to be absorbed on activated carbon in a bed filter or in a carbon injection system, in basically in the baghouse filter. So such systems are often found as polishing stage as the rear end of the standard flue gas cleaning system, and are called as polish filter. So this filter is called as polish filter. So this baghouse filter, it will again enters this activated carbon in the bed filter or in a carbon injection filter, and then they will start. So again, this system are often found as a polishing stage at the rear end of the standard flue gas cleaning system, and are called as polish filter. So this dioxin and furans will work, and it will be going to be already present in the MSW, but they are almost totally destroyed in the combustion chamber. And it will enters into the boiler, that when temperature will go rise like down like 200 degrees Celsius, again it will start activating. So to absorb this, some activated carbon bed has been installed into the baghouse filter, and where it will be often it will be absorbed, and it will be called as rear end of the standard flue gas cleaning system, and it is called as polish filter. Okay. Now comes to the next component, that is NOx, nitrogen oxides. It will be NOx will be considered some NO, NO2, NO3, all are considered under the NOx. So NOx is a common term for the nitrogen oxide and nitrogen dioxide. In waste incinerators, typically what happens, more than 95% of the total NOx in the flue gas is present as a nitrogen oxide. If the combustion temperature drops down below 850 degrees Celsius, if the temperature will drops down below 850 degrees Celsius, an increasing fraction of the NOx is present as a N2O. And N2O are extremely high greenhouse gas potential of 310 compared to 1 for CO2. So this NOx is a very dangerous gas, and it is extremely high greenhouse gas potential of 310 compared to the 1 for CO2. NOx is a common term, and in NOx it will all will be considered either NO, NO2 or NO3. So if the combustion process temperature drops down below 850 degrees Celsius, an increasing fraction of the NOx is present as N2O. And this N2O is a very extremely dangerous greenhouse gas, and it is having a potential of 310 compared to 1 for the CO2. Okay. So for the removal of NOx, two things has been used. First is the selective non-catalytic reduction and selective catalytic reduction. SNCR, SCR. So what happened? SNCR is called as selective non-catalytic reduction. So in the SNCR, it is going to use ammonia or NH2 containing compounds into the secondary combustion chamber. Ammonia and ammonia and NH2 containing compounds, to reduce into the secondary combustion chamber of the furnace for the reduction of NOx to N2. And the minor quantity of N2O is also formed. So some small quantities, some minor quantities of N2O are also formed. So this is called a selective non-catalytic reduction, SNCR, which is using mostly ammonia and some ammonia containing compounds into the secondary combustion chamber into the furnace for the reduction of NOx to N2O. And sometimes what happens, some little bit quantities of N2O is also formed that may be dangerous also. So like this, this chemical reaction will happen. NO is combined with CuNH2 compound containing, and then oxygen will come out, nitrogen, CO2 and H2O. So this is nitrogen is coming out, so it is going to be reduced. Like that, NO is combined with some ammonia, and then again it will be reduced, only nitrogen will be there. So, and now comes to the next process, that is called a selective catalytic reduction, SCR. So reduction by ammonia to achieve at much lower temperature at the surface of the suitable catalyst. And the most common catalysts are based on the V2O5 stabilized in TiO2 and the zeolite materials. Selective catalytic reduction is like it can be reduced by ammonia, and it can be achieved at a very lower temperature and the surface of the suitable catalyst. And the most common catalysts are based on the V2O5 that is stabilized in the TiO2 and some zeolite materials also. Okay. So that is about the cleaning of NOx gases by the non-selective catalytic method and selective catalytic method. So, and this is all about the cleaning of flue gas system inside a system. Okay. Now, these are some of the references of some of the textbook that I have used in this study. You can also go to this textbook for the further study of all those equipments, all those things that has been installed. Okay. So, thank you for today's lecture. In this lecture, I have explained to you about the cleaning system of this flue gases, and for this cleaning system, which type of equipments has been installed and what are their efficiency, and these systems, how much efficiently it is working. So, and if you have any query, any question regarding this lecture, you can write a mail onto my given mail ID, that is that shikha.pandey@gmail.com. Okay, and you can write any query or to mail me. I will reply you. And thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.